Even with perfect geometry, a render can feel lifeless if the light fails to interact with your surfaces correctly. Look at how this dull setup transforms into a rich, cinematic shot once the light begins to define the shape and environment. Professional lighting relies on a layering process: three-point setups, real-world physics, and adding atmospherics. To build this alongside me, you'll need Blender version 2.8 or higher, any 3D model, and a downloaded HDRI and IES file, which we'll cover how to use. Mastering these techniques provides an essential layer of polish that helps your digital assets look grounded and professional. So let's jump in and start the build. Step 1 is establishing our environment. We do this by applying an HDRI, which is a 360-degree image that provides natural background reflections and a base layer of ambient fill light across the entire scene. A frequent mistake is dropping in an HDRI and leaving the default strength at 1.0. This often floods the scene with so much illumination that it washes out the subject and flattens your shadows. Instead, drop your HDRI strength down to around 0.15. This gives you just enough ambient fill and surface reflection while leaving plenty of room to craft your own lights. With the base environment set, we move to the three-point lighting setup. This serves to sculpt the shape of our 3D subject and pull it away from the background. Start with the key light. Position this main source of illumination about 45 degrees in front of your subject and angle it slightly downward from above to cast natural-looking shadows. This diagram shows the complete structure. Next, place the fill light on the opposite side of the key light to soften the dark areas. Then, drop a backlight behind the subject, aiming toward the camera, to trace the edges and give the model depth. By default, Blender's area lights are square. Real-world light sources rarely look like this. Change your light shape in the Properties panel from square to ellipse or disc, so your subject's shiny surfaces and eye reflections look natural. Your scene now has a solid structural base. However, a perfectly smooth digital light still lacks the physical imperfections we see in the real world. To add that realism, we need to consider practical lights. These are the physical sources that would actually exist in your scene, like a desk lamp or a candle. This diagram illustrates the inverse square law. As light travels, its energy decays proportionally to the square of the distance. Look closely at these fractions. Doubling the distance from the source means the area receives only 1/4 of the original light intensity. Default 3D point lights often ignore this physical law, casting a perfectly smooth sphere of light that doesn't decay naturally. We fix this by using IES profiles. These are downloadable text files provided by real-world lighting manufacturers that perfectly replicate actual light bulb fall-off patterns. To apply one in Blender, open your node editor and plug an IES texture node directly into your emission strength. Add a blackbody converter node to handle the color, and your lamp will emit mathematically accurate light temperatures. By enforcing the inverse square law through an IES profile, your lighting moves from a computer-generated approximation toward a physical reality. Professional lighting requires you to think about darkness just as much as illumination. Removing light to sculpt shadows creates true visual interest. On a real film set, directors use physical planes known as cards or flags to block out light and intentionally darken areas of the frame. You can recreate this tool easily. Add a simple plane to your scene, apply a black base color, and turn the roughness slider all the way up so the surface absorbs light rather than reflecting it. Position this card just outside your camera's field of view. It will block unwanted light spill on the foreground, helping the viewer's eye focus on the center of the frame. The final element is atmospherics, specifically volumetric fog to create light rays. Create a cube and scale it up until it covers your entire scene. In the shader editor, delete the default surface material and connect a principled volume shader directly into the volume output node. At first, your scene will turn completely gray and opaque. Just drop the density value drastically down to 0.05 or lower. You only need a subtle amount of fog for the effect to work. Aim a strong spotlight to cut through a window in your environment. The volumetric fog catches the beam, triggering visible, sweeping light rays. Integrating shadow casting cards with volumetric rays builds the cinematic mood and depth necessary to complete a physically accurate scene. Look at the layers we built: an HDRI for ambient fill, a 3-point setup, IES textures, light blockers, and final volumetrics. By relying on real-world physical behaviors, you eliminate the flat, lifeless look that often affects amateur 3D renders. Go ahead and save this project file right now. You can use this as your master lighting template to drop any future 3D models into. If you found this workflow helpful, hit subscribe. In the next video, we'll apply color theory to this exact setup to help you balance warm and cool light tones.